So at this point in our lessons on the binomial expansion theorem, we have learned how to deal with expanding things like 3x minus 2 to the fourth power. More than that, we figured out that we can take something like 3x minus 2 to the fourth power and extract just one term. Like if I wanted to know just the coefficient of x squared, we could do that. In this video, we're going to be learning about what happens if I have one expansion and then another expansion, and I'm asked in this to find the coefficient of, let's say, x cubed. I really don't want to have to expand this entire thing and this entire thing just to find this term. So in this video, we're going to be learning sort of a method or a shortcut that we can use to sort of pinpoint specific terms, specific coefficients in the product of two separate binomial expansions. Now I'm going to dive right into an example here. The method that we're going to use is that we're effectively going to expand each one of these things, or at least enough of it for us to see what's going on, and then we're going to look and think which of these terms would I need to multiply with which of these terms, like which of those would I need to do in order to get the term that I'm looking for. So for this example, we're being asked to find the coefficient of x, that's x to the first power, and the expansion of the product of these two things. And so what I've done here is I've sort of set up some boxes here. You'll notice that I have 6 boxes over here, and the reason I have 6 of them is that this first one is raised to the 5th power, and that means it's going to have 6 terms. Similarly, this guy over here is only raised to the 3rd power, so I put 4 boxes for myself over here. I'm not going to expand this entire thing, but I want to have enough of a sense of what's going on, okay? Remember, as we do these problems, that anytime we expand using the binomial expansion theorem, we always have some type of a combinatorial coefficient, and then we have the first term raised to a power, and we have the second term raised to a power. So what I want to do here, and I would encourage you guys, I'll do the first one of these, sort of this idea that if I was going to be expanding this 3x minus 1 to the 5th power, I know that I would have some combinatorial coefficient, and then I would have 3x to the 5th power and negative 1 to the 0th power. I doubt that that is really going to be used in figuring out the coefficient of x, because this guy's already x to the 5th power. This is way too big to contribute to this. So I don't really need to finish figuring this one out. What I'm going to do now is I'm going to go through and I'm going to fill in the rest of these boxes with what the beginnings of these expansions are. So if you feel comfortable doing that, go ahead and take a moment to do that now. So the next one of these is, again, a combinatorial coefficient, 3x to the 4th power, negative 1 to the 1st power, combinatorial coefficient 3x cubed, negative 1 squared. As I'm doing each of these, I'm not really going to expand them all the way out yet because I might not need them. I'm going to go ahead and just quick fill in the rest of these. So hopefully you have all of these sort of like frameworks for these things. And you'll notice I left all of the combinatorial coefficients blank. I didn't simplify any of these terms yet. And the reason is I don't want to do more work in this problem than I have to. This is supposed to be sort of a quick method that we can use to find these things. And so now the question that I would pose to you is, if you wanted to find the x terms, right, which of these expressions would you multiply together? Now you might be thinking that, sure, there's an x to the 1st power term over here, and that's true, but remember, in the full expansion, I'm going to need to multiply all of these terms with all of these terms. So thinking about the lessons that we've had before this, the only way that I'm going to be able to get terms for this thing that give me an x is if I multiply the x term from here with the constant term from here. And the one other way that I could do it is I could multiply the constant term from here, the one that doesn't have any x's at all, and multiply it with the x term from the second one. Now that I've identified which of these things I need, I can go back and figure out what the combinatorial coefficients for these are. So pause the video. If you haven't already done this, pause the video, sort of figure out what these combinatorial coefficients are going to be. So I can tell that this one here is going to be 5, 1. Sorry for my 5 there. This one here is going to be 5, 0. This one over here is going to be 3, 1. And this one here will be 3, 0. And so we can figure those out fairly quickly. The combinatorial coefficient for 5, 1 should be 5 factorial over 1 factorial, 4 factorial. That'll be 5. The combinatorial coefficient 5, 0 is going to be 5 factorial over 0 factorial, 5 factorial. That's going to be 1. So now that I've got these two combinatorial coefficients, I can actually multiply out what's happening over on this side. So we know this first combinatorial coefficient was 5, times the 3x is 15x, times negative 1 to the 4th power. That's going to give me a total of 15x for this term right here. If I do a similar thing for this next one, this combinatorial coefficient was 1. This is 1 times 3 to the 0. 3x to the 0 is another 1, so 1 times 1 is 1, times negative 1 to the 5th. That means this term here is going to be negative 1. Okay, so now I just need to go through a similar process and figure out what these two terms are going to be so that when I multiply them out, I can figure out what the coefficient of x is going to be. So similarly over here, I'm going to need to take a moment to figure out what the combinatorial coefficient for 3, 1 is. That would be 3 factorial over 1 factorial 2 factorial. That's 3. And then similarly, the combinatorial coefficient for 3, 0, that one's just going to be 1. So again, we're going to go through and do these. This would be 3 times x times 4, means this term is going to give me 12x. Here I'm going to have 1 times negative 8. That means this will be negative 8. Now that I figured out what these terms are, we can go through and we can multiply them as these lines indicate. I'm going to have 15x times negative 8. That's this multiplication. And then we'll have plus the negative 1 times the 12x. That's this pair of terms. And so going through and simplifying these things, we're going to wind up with, let's see here, that'd be negative 120x minus 12x gives me negative 132x. And so the question was asking for the coefficient of x. Our final answer here is going to be negative 132. All right, so here we have another example. Find the x to the 8th term in the expansion of the product of x squared minus 3 cubed times x plus 4 to the 4th power. I would strongly encourage you to pause the video and try the beginning of this one. Check back in, but give yourself an opportunity to try this one. So the method that we mentioned in the previous slide is that what we really want to do here is we want to sort of start expanding this thing. We know that this expansion would be combinatorial coefficient x squared cubed times negative 3 to the 0, and then it would be combinatorial coefficient x squared squared negative 3 to the 1st. And we're going to fill in all of these things, remembering that I don't need to actually expand any of these yet, because I really just kind of want to get the lay of the land. I want to get a sense for what is going to go into this thing, which of these terms would even have a chance of giving me x to the 8th. For the other one, we'll have our combinatorial coefficient x to the 4th, 4 to the 0. Then we'll have x cubed, 4 to the 1st, x squared, 4 squared, x to the 1st, 4 cubed, and x to the 0, 4 to the 4th power. Again, sorry, I've said this a few times. I'm not going to expand any of these yet because I really want to figure out what's going to give me x to the 8th. Okay, so when I sort of look closely at these things, I can sort of notice what powers I'm going to get out of each of these things, right? Like this thing here, this is going to give me an x to the 6th. If I could combine that x to the 6th with an x squared from over here, I'd be able to get x to the 8th. So does that happen anywhere? Sure, it's going to happen right here. I could combine this x to the 6th term with this x squared term over here. Okay, now is there anywhere else that this could happen? Well, let's see here. This guy here is giving me an x to the 4th. If I could combine that with an x to the 4th on the other side, I'd get another one. And sure enough, we see a place where that's going to happen, right? It looks like that'll happen between here and here. And the rest of these guys just don't really have a shot. Like if you look at these other options, this guy gives us x squared. I need to pair that with an x to the 6th. I don't have anything like that over here. Like these are going to be the only two terms that are going to result in an x to the 8th. So one of the important things for you guys to do in these problems is make sure that you found all of the possible ways that you can get up to that x to the 8th. As you hopefully remember from the last example that we did, the next thing we need to do is we need to figure out these combinatorial coefficients and then multiply the terms together. So if you're caught up to this point, pause the video again and give yourself a chance to do this one on your own. Okay, so this combinatorial coefficient right here should be the 3, 0 combinatorial coefficient, which is going to be 1. Okay, this one right here is going to be the 3, 1 combinatorial coefficient, 3 factorial over 1 factorial 2 factorial, that gives me 3. Great, so this is going to be 3. Moving over to the other side, this guy here will be the 4, 0 combinatorial coefficient. That's 1. And this one here will be 4, 2. That's 4 factorial over 2 factorial, 2 factorial. That's 4 times 3 over 2, which is 6. Okay. Now that I have those coefficients, I can sort of figure out what these actual terms are. If I multiply all of this stuff together, I'm going to wind up with, well, it looks like this is just going to be a pure x to the 6th power. This next one here, I'm going to have 3 times the x to the 4th times the negative 3, so that'll be negative 9 x to the 4th. Moving over to the ones on the other side, if I multiply all of this together, it's going to be x to the 4th power. And if I multiply all of these together, we're going to have 6 times 16. That's 96x squared. Now that I've got these terms, all I have to do is sort of follow these red lines that I had set out for myself. To get that x to the 8th term, I could do x to the 6th times 96x squared. And I could also do negative 9x to the 4th times x to the 4th. Expanding each of these, we get 96x to the 8th minus 9x to the 8th. And we can see here that this final coefficient is going to end up being 87 x to the 8th power. Oh, and the answering our, oh, no, the question here did ask find the x to the 8th term, so this time I'm giving the full term in this thing. This is the method that we use for finding specific terms when we're looking for the expansion of two binomial expansions that have been multiplied by one another.